This is our Chapter 21 lecture on carboxylic acid derivatives and nucleophilic acyl substitution reactions. Let's start by defining our carboxylic acid derivatives. If we start with just a plain old carboxylic acid, right, C double bond O OH, a carboxylic acid derivative is something that is derived from that, and that's a lot of the reactions we'll be talking about this chapter. These derivatives tend to have an electronegative leaving group attached to the carbonyl, as opposed to the OH. An acid halide has a halogen, like a chlorine or a bromine. An acid anhydride has O, C double bond O, and another R group attached to the carbonyl. So in each case, I'm circling the leaving group. An ester has an OR as a leaving group. Right? Remember, each case we use starting with RC double bond O and just changing what's attached to that carbonyl. An amide as an NH2. A thioester is just like regular ester except sulfur instead of oxygen. Acyl phosphate has OPO3 attached. So the whole point to having those leaving groups attached to the carbonyl is that it allows us to undergo this nucleophilic acyl substitution reaction. Take a look. When we have a nucleophile, it attacks the carbonyl carbon, right, because it's partial positive. That kicks electrons up onto the oxygen to make a tetrahedral alkoxide intermediate. Looks like this. RCO minus. Here's our nucleophile. They call the leaving group Y. I call it LG usually. So let's denote that. It's like that, LG. All right. So there's our tetrahedral intermediate. What happens then, remember when we had ketones and aldehydes before, without this leaving group, we were just sort of stuck there. Okay? We would get it protonated to make an alcohol or lose water or something like that. But because of this leaving group attached, the electrons in the O minus come back down and kick off the leaving group. So 2 steps to this process here, right? The first step is addition, where the nucleophile adds and it makes that tetrahedral intermediate. Then it's elimination, where the O minus comes back down, displaces the leaving group out from there. So the aldehydes and ketones we talked about just did that addition. By having this leaving group as part of it, we can add this elimination. And overall, addition plus elimination makes for a substitution reaction. In order for substitution to happen, we have to add something and then get rid of something else. Okay? So that's our overall substitution. The nucleophile switches place with the leaving group. And throughout this chapter, if you're able to identify the nucleophile and the leaving group, and if you just simply swap them, you're actually in pretty good shape for most of the reactions we'll do in this chapter.